Let's not make this harder than it is. It's time for a test. Okay, this is not a test like, all right, get out your paper and pencil. This is a test like, how do I determine if a function is increasing or decreasing? And I'm going to use the first derivative to do so. I'm going to use the first derivative to make that determination. So given the graph of the function below, state the intervals. I'm going to be referring to x values on which the function is increasing, decreasing, or constant. I think the constant one's going to kind of stare you in the face. I think it's somewhat obvious. So let's just jump right in. And this function is increasing anytime it's going up. Now we have to look from left to right. So the function's going up, going up, going up, going up, going down, going down, going down, going up, level, down, 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 down. Okay? Increasing, decreasing, and constant, that's when it's going up, going down, and, well, flat. I think it's pretty straightforward. Well, that one definitely is straightforward. Ha get that? That's funny, isn't it? Yeah, I think so too. Okay, the function is increasing here. Where is here? Let's talk intervals now. So, negative infinity. Now, I'm pointing down when I say it, but I'm really pointing to the left. So, the function, from as far back as I could draw it, up to that x value, negative 3, is increasing. So from negative infinity to negative 3. And I'll put a parenthesis there. People don't get too picky about that. Some people put a bracket and say that the function is increasing from negative infinity to negative 3, including negative 3. Technically, at negative 3, it's leveled off. Like when you're riding a roller coaster and it kind of goes like that, you're neither increasing nor decreasing. But people don't normally make a big deal out of that. I like parentheses, though. Okay, then we go down, and then we come up again, and we're coming up from 2 to 4. I'm looking at x values now. So from here to here, from 2 to 4. So 2 to 4, and we'll join them with that mathematical symbol, union. You could also use the word or. It means the same thing. All right, the function is decreasing from here to here, and that is negative 3 to 2. Negative 3 to 2. And is decreasing from here and forward. That one's linear. It's pretty straightforward. There's that joke again. So positive 6 to infinity, the function is decreasing. So from 6 to infinity. And there is only one interval where the function is constant. That is from 4 to 6. Okay, the next part is going to be so easy, you might just cry. Let's just jump straight to that third one. A function is constant on a, b when, all right, let's talk derivatives because that's what we're dealing with. This function right here at this specific place has a derivative that is equal to 0. If I asked you, what's the slope of this line, this little piece of the line, it would be 0. So this is where the derivative is equal to 0. Well, if a function is constant where its derivative is equal to 0, then a function is, we're talking about the first derivative now. A function is going to be increasing when it's going up, right? Right? Okay. The function's going up here. When the function's going up, its slope is positive. If I was to draw a tangent line at that point, I'd draw something with a positive slope. If I drew a tangent line at that point, it'd be a positive slope. They wouldn't be the same slopes, but they'd be positive. So where the derivative is positive, greater than 0, and the function is, whoops, there's a typo on my paper, and in later versions of these notes it won't be there. But this one should say decreasing. My apologies. And again, I think it's fairly common sense. Function is increasing when the slope is positive, decreasing when the slope is negative. You can just think of linear things. Positive slope, negative slope, increasing, decreasing. Sorry for the typo.